Free body diagrams. A free body diagram is a sketch that is used to show all the forces acting on an object, or a system of multiple objects. Once the free body diagram is drawn, Newton's second law is applied to solve for unknown forces or the motion quantities position, velocity, and acceleration. First, we draw a dot to represent the object. Then we draw an arrow from the dot pointing in the direction of one of the forces that is acting on the system. Label that arrow with the name of the force. Make sure the arrow touches the dot, right from the dot outwards. Then repeat for every force that is acting on the object. Try to draw each of the arrows to roughly the same scale, larger forces getting larger arrows. Once you've finished the free body diagram, recheck it to make sure that you have drawn and labeled an arrow for every force. This is no time to forget a force. Then draw a separate arrow next to the free body diagram, indicating the likely direction of the acceleration of the object. Forces that are in the same direction as the acceleration will be positive. Repeat this process for every object in the sketch. All of the forces covered in this course are contact forces, except for one, gravity. Gravity is a force that acts at a distance, like electric and magnetic forces. Contact forces result from two objects making physical contact with one another. Here are some examples. Normal force, friction, pushing, pulling, tension, or spring. When drawing a free body diagram, consider everything that is physically touching the object. When representing the gravitational force in a free body diagram, there are a few acceptable ways, including labeling it F sub g for the force of gravity, mg, which is the equation for weight or the force of gravity, or capital W for weight. It is unacceptable to label gravity with just a little g. Little g by itself is just acceleration, not weight. You can also not label it little m. Little m by itself is just mass, not weight. Mg, however, is acceptable. A free body diagram makes it clear if any acceleration will take place. Treat the x and y dimensions separately. In the free body diagram below, in the y dimension, the forces cancel out. The normal force equals the gravitational force. Force up equals force down. Therefore, the object will not accelerate up or down. In the x dimension, there is an unbalanced force, force applied. Therefore, the object will accelerate to the right. Acceleration will always be in the direction of the unbalanced net force. Unbalanced forces lead to acceleration. An object moving at a constant velocity might have a free body diagram that looks exactly like the free body diagram for a stationary object. Here, the object represented by this free body diagram might be moving at a constant velocity, or it might be at rest. There's no way to know. Acceleration does not indicate direction of a displacement or velocity. It just indicates how the velocity changes with time.